Hi guys, we're going to do another chapter 3 video, and you may or may be not be watching this when you're in chapter 3 in our class. You might be going back and doing some review, which is kind of what this video is. And the topic, the essential question is, what is the difference between vertical and horizontal slopes? So it's not a brand new topic to us, but it's something that we're making some common mistakes on and we need to practice more. So let's talk about vertical and horizontal slopes and what that really means. And in our notes, here's what I'm going to do today. I am going to draw a graph. So let's make an XY axis. It doesn't have to be huge. Make it look like this. Here's my Y axis, label it. And my X axis, hopefully you have a ruler and you can set up a nice graph in your notes. Something like that. And then what we're going to do is kind of quickly throw on some scale numbers so we have some numbers to kind of work with. So I'm going to go through with my pen here and just mark my scale on my graph paper. We are experts at graphing at this point, so we're pretty good at this. And let's see, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, just kind of get some labels on here. Negative 1, negative 2, negative 3, negative 4, negative 5, some basics. All right, so what are we graphing on this graph? Well, here's what we're going to do. We're just going to plot some points, actually. And what we're going to do is pick a spot to kind of focus on. So I'm going to choose to focus on y equals 3. So 1, 2, 3, right here. And what I'm going to do is I'm going to plot some points that land at that location. For instance, I'm going to plot the point 2, 3. I'm going to plot the point negative 5, 3. And I'm going to plot the point positive 5, 3. And we're going to put those 3 points on our graph. So let's see here. 5, 3. I'll go backwards. 5, 3 would be here's 5, here's 3. Negative 5, 3 would be on the opposite side right here. And 2, 3, here's 2. 1, 2, 3. And if this is all I knew, I can see that it's a line, but it's one of our flat lines. So what I'm going to do is line this up. Looks totally flat. I'm going to connect my points like this. And on top of it, I'm deciding I'm going to label it a function today. It's f of x. It's a function. All right, so here's my totally flat line. Well, what do I know about my flat line? Well, I definitely could analyze the slope. So thinking slope here for a moment, if I wanted to make a growth triangle, I think that would be pretty challenging to do with a flat line. So instead, I'm going to look at it as like a delta y over delta x situation. Change in y and change in x's. Remember our formula? y2 minus y1 over x2 minus x1. I'm going to find the slope using the formula. And in this problem, I'm going to have to pick which 2 points I want to use. It really doesn't matter. So up here, maybe 2, 3 could be my x1, y1. And negative 5, 3 could be my x2, y2. Kind of picking those at random. And if that's what I'm going to choose, then y2 minus y1, let's see, the y's are 3 and 3. So it's going to be 3 minus 3 over x2 minus x1. So that'd be negative 5 take away 2. Okay, well, here's what I know. 3 take away 3 is 0, and negative 5 take away 2 is negative 7. But fractions mean divide, and 0 divided by negative 7 is really just 0. So what kind of slope does our line have? Well, it has a slope of 0. So what I know is that my m from my mx plus b is equal to 0. Totally flat line, totally flat slope, so a slope of 0. Remember what slope measures. Slope measures steepness. How steep is the line? Well, if it's completely flat, it's not steep at all. If it was super steep, it'd be hard to climb up it. Picture like hiking a mountain. If I had to hike on this line, it'd be just a stroll. It'd just be going on a walk. It'd be really easy, slope of 0. So if m is equal to 0, what about b in our mx plus b? What is b equal to? Well, we do have a y-intercept. It's right here at 3. So b is equal to 3. So technically, we do have an equation of our line. I'm going to write it down below down here. Our y equals mx plus b. Our m, maybe I'm running out of space here, but our m is 0, but our b is 3. So it's like y equals 0x plus 3. Nobody writes 0x though, so what are we just going to write? Well, y equals 3. Totally makes sense too, because where does the graph cross through? Y equals 3. Look, goes through 3. And think about it, as you travel along the line to all these different points, every time you hit a point, it's y equals 3. Y equals 3, y equals 3, y equals 3, everywhere you go. So hence, we say our function f of x is equal to 3. It's just that solid point. So that's what we call a flat horizontal line. So I'll write a little note over here. This is horizontal. But what about vertical lines? Let's talk about vertical lines, because those are kind of the opposites of this. So we got our horizontal line. Let's do a vertical example. So in your notes, make a brand new graph, same size. So I'm going to make a nice new y and x axis here, just to keep it nice and neat. Something like that. Something like this. There we go. Same thing, I'm going to throw in some scale numbers, kind of make it look nice and neat. So use my pen here. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. There we go. All right, here's our graph. Now let's look at a vertical line. So I'm going to write vertical. We've seen a horizontal. Let's look at a vertical. So a vertical line is a line going straight up and down. So I would have to pick a place as my point. So here's what I'm going to go for today. I'm going to plot some points at 2, 4, and 2, 1, and 2, negative 3. Those are going to be my points that I'm going to plot on this graph. So go to 2, 4, 2, 1, and 2, negative 3 and plot your points. So here's 2. So 2, 4 would be 2, 1, 2, 3, 4. And 2, 1 would be like here, at 1. And 2, negative 3 would be 2, 1, 2, 3, negative 3. And there it is. There's our vertical line. You can see it going up and down. If I take my ruler up against it here, you definitely can see. So here is my vertical line, which is a kind of a special case. Why is it a special case? Well, let's think about its slope. What could m equal? We definitely can't draw a growth triangle. So we're going to calculate slope using our formula and see what do we get. How steep is this line? So our delta y over delta x is going to be our y2 minus y1 over x2 minus x1. And we're going to pick 2 of the points. It doesn't matter which ones. How about this one? This can be my x1, y1 for 2, 1, x2, y2. There we go. Okay, so starting with y2 minus y1, we've got, let's see, negative 3, take away 1, negative 3, take away 1, and then x2 minus x1, that's going to be 2 take away 2, 2 take away 2. So on bottom we get 0, and on top, negative 3 take away 1 is negative 4. So negative 4 over 0. Now, have you ever tried to put something divided by 0 in your calculator? Have you ever tried that? Calculators kind of freak out when you do this. Let me show you. I'm gonna put in negative 4, and I'm gonna divide it by 0 and see what my calculator says. Hopefully you guys can see it. Error. My calculator freaks out. Now your calculator, no matter what brand or type you have, is gonna do the same thing. And there's a reason for that. You can't divide by 0. That's impossible. There's no dividing by 0. No divide by 0. It seriously is impossible. Because remember what division is. Division is grouping. So let me give you an example here. I'm going to grab a stack of paper clips. Okay, here's my paper clips. I've got 3 of them. Divide them into 0 groups. Okay, well right now it's a group of 1. If I separate them out, now I have 3 groups. Even if I make them uneven into 2 groups, how do I make 0 groups? The only way I make 0 groups is they disappear. So it's impossible to make 0 groups unless you're going to like take something completely away. It doesn't make any sense mathematically. So, because you cannot divide by 0, here's what we say for our slope. We say it's impossible. Well, we call that undefined. It's undefined slope. And think about why that is. Slope measures steepness, remember? Steepness is what we're talking about. So if you were hiking on this line, how steep is it? Oh, it's wicked steep. It's a cliff. It's a drop off. In fact, if you were to get to the top of it and say, I'm going to hike this mountain, all you're going to do is free fall. So the slope is so steep, it can't be measured. It's unmeasurable. And that is very, very different than a flat slope, like in our first example. This is easy to walk across, totally flat, no steepness to it, but it's not like this. This is undefined. This is like a cliff edge. So our m equals is undefined. How about our b? What's our y-intercept? Where does it hit the y-axis? Never hits the y-axis. It's also undefined. There is none. So I'm just going to say there's none. So to write our equation is a little bit tricky for this one. So we kind of have a unique situation. Here's what we do. We say, oh, well, the equation of this line, the one thing I know is every time I go to a point, it's at x equals 2, x equals 2, x equals 2. So our equation is x equals 2. There's no y equals mx plus b because there's no m and there's no b. So x equals 2, and that's our vertical line. So notice when we had a horizontal line, we had the equation y equals 3. When we have a vertical line, it's x equals. So vertical is always in the x equals format, and horizontal is always in the y equals format. So kind of something to note. And if you wanted to take this one step farther, imagine I was like, okay, well, go make a table for this situation. What would our table look like? Let's think about that. We know what the graph looks like. We get that. What would the XY table look like? So I'm going to make some XY points and put them in my table. Well, for this particular graph, all the X values are at X equals 2, every single one of them. So all I'm going to have in here is 2, 2, 2, 2. And I could list out, well, millions of points. I could go forever. I could say, well, here it's at 2, negative 3, 2, negative 2, 2, negative 1, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. So, I mean, it'd be really easy to be like, well, it's at negative 3, and then negative 2, and then negative 1, and then 0, then 1, then 2, but all at x equals 2. So the table is going to look the same for the x values, and then the y values are just going to increase, basically. Versus like this thing, the first problem, what if I had said, hey, let's make a table for this. What's the table going to look like for this one? Well, the table for this one's going to be a little bit different. Let's make a table in our notes here. So we'll write table. Find some space in your notes to make your table. Think about it. If you made an x, y table for this one, this time, all the values of the line are at y equals 3. 3, 3, 3, 3. So you could go like negative 2, negative 1, 0, 1, 2. You could go kind of classic on your table, which is usually what I typically do, is just use negative 2 to positive 2. But if I go from negative 2 to positive 2 on my graph, they're all at 3, 3, 3, 3, 3. 3, 3, 3, 3, 3. So you can kind of see some trends in these tables. All right, guys, so that's going to kind of wrap up our video, and I hope your takeaway from all of this is just kind of noticing that horizontal lines are going to always be written in the y equals format with a slope of 0. They're flat. And vertical lines are always going to be written as x equals, and they're always undefined slope. You can't calculate their slope. It's totally impossible. So that's kind of the big major difference. Thanks for watching. I will see you in the next video.